In these slides, we will go through some examples of delay barriers. In the overall process of the depot methodology, delay is the second of the three main components of the physical protection system. The purpose of delay is to allow enough time after detection for the response force to interrupt the adversary. These pictures show some examples of delay barriers. The picture on the top left is an example of a retractable vehicle barrier. The barrier can lay flat, allowing vehicles to pass, or can be activated and stop vehicles that are attempting to enter the facility. This serves a significant delay purpose because if the adversary is forced to go on foot rather than by vehicle, it will take them much longer to traverse the same distance. In addition, the adversary would have to carry their equipment, which limits the amount they can take and can slow them down further. It also keeps possible vehicle-borne improvised explosive devices away from buildings, which may be critical for successful security. These barriers come under extensive testing, the videos of which are available on the internet if you search for vehicle barrier tests. On the top right, there is a picture of a vault. This picture demonstrates an important concept that must be kept in mind with delay barriers and physical protection system design. The daily operation of the facility must be considered when installing delay barriers. While the vault door provides a lot of delay when it is closed, it provides none while open. The vault door is likely too heavy to be opened every time someone enters the vault. If it is left open during normal operation hours, then compensatory measures would need to be taken by the security system to account for this. On the bottom left, there is an example of a dispensable material. Dispensable materials can be activated remotely or triggered by certain alarms and can enhance surrounding delay barriers by increasing the complexity of the task that the adversary must complete. The smoke machine in the picture essentially takes away the adversary's ability to see, which will undoubtedly impede his progress. The bottom right picture shows an explosive breach test on a concrete wall with mesh reinforcement. When analyzing an adversary path, entry routes other than doors and windows must be considered. With walls, it is important to keep in mind that the adversary only needs to produce a hole big enough for a person to crawl through. Explosives can provide a fast means of breaching barriers and must be taken into consideration when evaluating the security system. This picture shows a variety of tools that might be useful to an adversary planning to break into a facility. Many of these tools are available at typical hardware stores such as axes, pry bars, bolt cutters, saws, cutting torches, and hydraulic jacks. All of these tools must be taken into account when analyzing the delay capabilities of a barrier because they are easily acquired by an adversary. This is an example of a data sheet on the delay characteristics of a barrier. The barrier is a 10 cm thick concrete wall that is reinforced with 6.4 mm rebar at 15 cm intervals. You can see that the time to penetrate the wall varies greatly based on the equipment that the adversary uses. With a sledgehammer and bolt cutters, it takes on average 4 minutes to penetrate the wall, while with 10 pounds of explosives, it takes 96 seconds. Also notice that the data sheet has the total weight of equipment required to breach the barrier, which is important to keep in mind when analyzing multiple barriers because the adversary is limited by how much weight they can carry. Here we have two graphs that show standardized rates that can be used to systematically and consistently assign how long it takes for an adversary to traverse an area. For example, running 200 meters from a fence to a door. The graph on the left shows different running rates. The multiple lines represent running speeds under varying conditions. Logically, the adversary will run slower when carrying more equipment or when on terrain that is not solid. For instance, on sand or gravel versus pavement. The graph on the right represents movement speeds for various vehicles and will be based on the type of terrain being traversed. In this case, the terrain is a road with a 90-degree turn.